Today is day 3 of Unit 2, Proportional Relationships. So today we are going to talk about what makes two quantities proportional. What makes two quantities proportional? This is our essential question today. You should be able to answer this by the end of the lesson. So let's get started. So last lesson we talked about proportions. Remember proportions, the first day of this unit we talked about rates and ratios. And when we talk about a rate or a ratio as a proportion, we're going to be setting two ratios equal to each other. So we're solving a problem. So we actually have to set up an equation and we're setting them equal to each other. So to see if something is a proportional relationship, we're going to see if the proportion works. Okay? So if a relationship is not proportional, that means that we can't represent them as equal ratios. So for example, that they give you here, a person's age and height. So just because you are 10 years old doesn't mean that you are a certain height, right? Everybody is a different height, everybody grows at a different rate, so that wouldn't really be a proportional relationship. So we're going to be looking at what things, what quantities will be proportional. And again, we're going to have numbers to justify this. So example number 1, Derek counted 24 marshmallows in 3 servings of marshy morsels. Sounds delicious. At this rate, how many marshmallows are in 12 servings? So the first thing I want you to notice is it says how many marshmallows are in 12 servings. So what that means is that our ratio is going to be marshmallows to servings. Okay? This is something I want you to get used to doing. Okay? If we're just looking for a missing value, then it really doesn't matter which one goes on the top. But what matters is the consistency. And you see that we point that out right here. So, for example, if in one, as you can see, in this ratio, we have marshmallows on top, servings on the bottom. In the second ratio, we also have marshmallows on top and servings in the bottom. So even if you flipped and did servings on the top, both the servings have to be on the top. All right, so we need to keep that consistency, and that's the only way that we're going to solve this proportion correctly. Okay, so you have to be careful about those units. Okay, so now we're talking about rates. Okay, so when we have our rates have units. Remember, that's the difference between a rate and a ratio, is rates have units. A ratio is just a comparison of two numbers, two quantities. Okay? So what we're going to do first is we put what we have already know. So we already know that 24 marshmallows in 3 servings. We want to know how many marshmallows would be in 12 servings. So what we're going to do is we're going to set up a proportion. All right? And then the next thing we're going to do is one of two things. Now, I know some of you like to cross multiply. You absolutely can cross multiply. All right? Or you can also, sometimes when we have certain numbers, we can kind of look at them this way. So you would have 24 over 3 is equal to m over 12. So I would ask myself, okay, looking at 3 to 12, how would I have to get from 3 to 12? Well, I know that I would have to multiply by 4. So remember, we are working with ratios, which are fractions. So whatever I do to the denominator, I have to do to the numerator. So I know that I'm going to multiply it by 4. So these are the things that you should be doing in your thought process of solving an equation. Or again, you can set this up like a proportion and cross multiply. Remember, cross-multiplying, we find the cross products. So we multiply across, and then we would divide and solve for m. But either way, you're going to get 96 marshmallows in 12 servings. Okay, the next thing we're going to talk about is that in a proportional relationship, when one quantity increases, the other increases. So obviously, if one decreases, the other should also decrease. So the ratio of two quantities stays constant in a proportional relationship. And what we call this constant is the constant of proportionality. Okay, so the constant of proportionality, all right, this is the constant ratio called the unit rate or the constant of proportionality. So this will make more sense when we discuss graphing. We're always going to do the constant of proportionality. So this letter, and I want you to write this down, we represent this as letter K. Okay, so K is the constant of proportionality. We use that variable. All right, so let's look at what that means. So a train travels 120 miles in 1.5 hours. So remember, miles in, that's the same thing as per, okay? So this is going to be the numerator, this is going to be in the denominator. You should always think that way. Remember, time is always in the denominator. At this rate, how many miles can it travel in 5 hours? So again, it really always is helpful to write your ratio without numbers. You know that miles are going to be on top and hours are going to be on the bottom. This is important when you're talking about a unit rate, because when you do solve this and put this into your calculator, remember this is always, a rate is always a fraction. Fractions mean division. Okay, so we're going to divide, and the unit rate is 80 miles per hour. All right, remember this right here represents the word per. Sometimes we say in, but miles per hour. Okay? All right, so now we have to answer the question. So whenever you are trying to figure out, so a comparison of two rates or ratios, we're setting them equal to each other, it's easiest to find your unit rate first. That's going to make it easy. But another thing you could do is you can go straight to a proportion and use the cross products. Okay, you can use cross multiplication so that you don't have to find the unit rate first. So what we did here is we found the unit rate to be 80 miles per hour, and then we took that and we multiplied it by how many hours we want. Okay, that's what we are used to. But a shortcut would be to use what we learned. Okay, we can use our proportions. We set them equal and then we cross multiply. All right, so if we cross multiply, we're going to get our variable by itself. Okay, remember this is multiplication. The opposite of multiplication is division. So our final answer would be, again, 400 miles in 5 hours. So it doesn't matter which way you do it. Just make sure that if you do it this way, that you write your answer like this. Okay, the word problem. You always got to answer your word problem in a sentence. Okay, so our last question, last example. 18 is what percent of 60? So, just to refresh you guys, I told you that is over of is equal to your percent over 100. This is a type of proportion. All right, so it says 18 is what percent? So whatever the question is, so when I put the box around, that's what your x is going to be, of 80. All right. Another thing to say instead of is and of, sometimes we say part and whole. And later on I'll talk to you why we don't always say part and whole, but usually it's going to be part and whole, and then percent is always on the top, and then 100 is always on the bottom. Even if your percentage is over, maybe your part is bigger than your whole, so the is bigger, then your percent is going to be bigger, but we'll cross that bridge when we get there. So again, you set this up as a proportion, cross multiply, so we get x is equal to 30. Last thing, make sure that you actually answer the question. 18 is 30% of 60. All right. Okay, so I'm going to break down this coached example with you. I think it's a great example, and I also want to make sure that we are practicing how to go through a word problem and properly underline things. Okay, so Mr. Collins is planning a party for his homeroom class. So I like to cross stuff out that I don't need. That's irrelevant. There are 30 students in his class. Okay, that's important. He wants each student to have a serving of 8 fluid ounces of juice. That's important. Each jug contains 40 fluid ounces. So at this rate, we want to know how many jugs of juice we need. Okay? So the first thing, write the number of fluid ounces for each student. So again, we are just breaking down, and I've underlined all the important stuff that we're going to put down here. So 8. Next, write the number of fluid ounces in each jug. They told us 40. Okay, to find the unit rate, write a ratio that compares the number of fluid ounces in each jug to the number of fluid ounces for each student. Okay, so this is fluid ounces to each student. So ounces to students. So we're going to do 40, I'm going to write it off the line, 40 over 8. Okay, so we're going to simplify that ratio. Hopefully you guys can do 40 divided by 8. So 5 servings per jug. So to find the number of jugs we need, we are going to divide the number of students in the class by the servings per jug. Okay, so essentially all we're going to do is we're going to have 1 serving per person. All right, so I'm going to do 30, all right, not 30, yeah, 30 students there are. So 30 divided by 5, so 6. So Mr. Collins will need 6 jugs of juice. All right, again, be very careful. This is a great way to break down your word problem. All right, so go ahead and look at the board and write down your homework and get started. Thank you.